Okay, it's time to invite our sixth speaker. We're running a bit behind, but it's a good thing we had a wrap-up session at the end. Alexander?
Hello, everyone. How are you doing?
Wonderful. So you are known as the main Patroni author. You work on that project. You now work at Microsoft, and Patroni is a pretty famous high availability solution for Postgres for anyone who's not familiar. And you're going to talk to us today about Patroni together with Citus, right?
Yeah, exactly.
Awesome. Well, let's let you dive in. Let's go.
All right. So Postgres is a wonderful database in all aspects. It's very fast, it's very flexible, it's extensible, but it comes, unfortunately, with batteries not included. What does it mean? If you want to have automatic failover with Postgres, you have to use some external tools. Or if you want to scale it out horizontally, you also need to use something external like Citus. And today I'm going to talk about how to make Postgres rock using Patroni and Citus together. And yeah, so what is this talk about? First, I will do a short and brief introduction to what kind of problems we are trying to solve. Then, naturally, we will speak about how to make Postgres highly available using Patroni and how to scale Postgres horizontally using Citus. And as a next step, we will use all these three tools together to have the best solution. Of course, this presentation will include a live demo, and at the end, we will have a short wrap-up session. So let's try to scope our problem that we are trying to solve. Usually, when you are a business or application developer that works for a business, you want to have a database to use from the application. And database could be totally different in the real world. It could be even something embedded like a SQLite, which is also a wonderful database. But if you want to have a database highly available, it must be connectable from many different sources, from different components of the application. And you need to run a primary and a standby. And in case of primary fails, you want to have it failing over to a standby. The next thing that people naturally want when business grows, you want to be able to scale out or scale up depending on the business needs. And scaling means two different things. It could be scaling up vertically, like you want to throw more hardware you want to buy a bigger machine and scale out vertically, or better, you want to scale out horizontally. That opens totally new perspectives. And last but not least, we want to do it for free. Like, of course, you can buy a ready solution from any of the cloud providers that will allow you to scale Postgres even horizontally. But it's not always possible to run your business on the cloud. Sometimes there are strict requirements and you have to stick with on-premise. You have to stick with the real hardware. And therefore, we want to have something that is available and better for free, because the best beer is the beer you get for free. All right, so with choosing a database, it's very simple. First of all, we are a Postgres conference, and using a Postgres is out of the question. And this picture I took from Postgres website, as well as a quote that Postgres is the world's most advanced open source relational database. So we will use Postgres. And to make Postgres highly available, we will use Patroni. So if you're not familiar with Patroni, it's a daemon implemented in Python. It runs next to a Postgres processes, and in order to figure out which node should be running as a primary, Patroni relies on a distributed key value store, such as etcd, Consul, or Zookeeper. And those are probably three most widely used and most well-known distributed key value stores. To provide a single endpoint and for the applications which will connect you always to the primary, we typically recommend using a tool like HAProxy or any kind of TCP load balancer that may choose the node which is running the primary by running a health check, REST API health check provided by Patroni. Basically, HAProxy simply calls HTTP endpoint on the Patroni on every node, and Patroni responds with HTTP status code 200 when node is running the primary. And in case if it's at standby, it will respond with code 503. Actually, HAProxy could be also used for a different purpose. Like it could be doing a different health check and exposing a different port to do load balancing across multiple standbys. So how to scale Postgres vertically? Well, how to scale Postgres? Like the first one, which is very obvious and available for anyone, you just throw more hardware. You buy a bigger virtual machine, or you buy a better server, and you set it up. You, as a standby, you do a switchover. So the node which is currently as a standby will be a new primary, and the old primary could be decommissioned and also rebuilt on the bigger hardware. But as we know, and as Marco noticed in his keynote, abilities to scale vertically is not infinite. At some moment, you reach the biggest possible machine that you can buy, and you are locked. And resolving the situation, it could be very tough. Therefore, people, when they have in mind solving of scalability problems, consider doing sharding from the early stages. How does it work? Instead of running just a single Postgres instance or single Postgres cluster, we run multiple Postgres clusters, and our data will be spread across those machines, across those clusters. The way how you spread the data across different machines or shards could be as simple as we divide some identifier, which is used as a sharding key, and take the reminder of this division. And in case if we have only 4 shards, we can take a remainder of when dividing by 4, and the remainder will define the shard ID. It's very simplified. The real solutions, of course, not using this approach, or maybe they do use this approach, but with application level sharding, there are definitely pros and cons. The main advantage of application level sharding is that application connects directly to every shard, and latency is very minimal. So it does not see difference comparing when it works with just normal Postgres, because it is a really normal Postgres without any hacks. But there are at the same time plenty of disadvantages when you use application level sharding. On the application side, you have to know to which database, to which shard you have to send query to, and therefore you need to have a dedicated connection to this machine. When you build your database, or when you build your application, you have to think about sharding from the day one, and you have to think about data locality. It means that for a given customer, you have to store all orders that this customer makes on the same machine, on the same shard, in order to perform joins effectively. And actually, with application level sharding, I would say it's very close to impossible to do cross-shard joins. it's also very tough to add new shards, especially in case if you shard by a reminder of your sharding key. And but at the same time, you may invent something better and shard by using different strategies. So adding new shards will be possible, but when you add new shards, they will be heavily disbalanced. They will have no data and they will receive no queries. And only after a significant amount of time, they will get some new data and maybe somehow system will become balanced. Enterprise solution should support rebalancing of existing data between old and new shards, and preferably without downtime. And it's actually a huge challenge. And last but not least, when you develop your application, when it evolves, you also have to do some changes in the database. And since you have not just a single database, but the whole bunch of them, all changes must be deployed to all shards. And in case if you fail doing so, application may start behaving unexpectedly. And Citus is a solution to Postgres horizontal scalability. Instead of doing all this stuff in the application side, Citus provides a single endpoint where you can do everything to shard your data. In the Citus, there are two concepts. There is a Citus coordinator, which normally is used for application to work with the data. And also, what is important, your application will use a coordinator to change schema, to create new tables, to make them distributed. You may also, of course, insert data into those distributed tables. And under the hood, coordinator will parse those queries, rewrite them, and send them to a set of workers, which are known also as shards. With Citus, of course, there are plenty of advantages, but one disadvantage is because we have to parse the query, we have to do additional catalog access, Postgres catalog access, we have to construct new queries and send them to worker nodes. At the end, we get some additional latency, which is a performance killer, as also Marco noticed. But I believe there are plenty of advantages from Citus. It's transparent for the application. So not totally transparent, because when you design your database schema, you still have to think about data locality and you have to put some collocated data. So you have to design schema in a way that collocated data will be placed on the same shard, on the same working node. But from the application, you connect to coordinator, and therefore there is not so much changes comparing when you connect to just a single Postgres. It's a single connection pool, but at the same time, Citus provides you ability to connect to any of the worker node and also run any query, and it will work the same way as it works with coordinator. Although you cannot deploy currently schema changes via the worker nodes. And what's the biggest advantage of Citus? You can start with small. You can set up originally just a couple of worker nodes, and when your business grows, when the amount of data grows, you can add some additional worker nodes and scale out. And what's more important, if you did your homework good, so if you created schema in a way that it could be, it has all primary keys or has some unique keys, that it could be rebalanced without downtime using logical replication, which is again available on Citus for free right now. How we can combine those two solutions together? How we can make Postgres highly available and scalable at the same time? Of course, we can again deploy multiple Postgres clusters with Citus extension, one coordinator and a bunch of worker clusters. And under the hood, Patroni using the distributed key value store like etcd, Patroni on the Citus coordinator can discover all existing Citus workers that also registered in etcd, and it will automatically register every new worker which is added on the coordinator. What's also interesting, when the roles of nodes in the workers are changing, when standby, for example, becomes primary because the old primary failed or because we did a switchover, the Patroni on the coordinator will update Citus metadata to reflect those changes automatically. You don't have to do anything special for that. And application will, as I said, will just connect to the coordinator, or in case if there is a demand, there may be a special HA proxy running just for accessing worker nodes and doing load balancing across workers to send queries to. How to enable Citus support in Patroni? It's fairly simple. There are just a couple of simple rules that one needs to follow. If you're already using Patroni, you're familiar with Patroni config file. If you are not, it's actually pretty simple. The scope or cluster name must be the same for all clusters of our Citus cluster deployment. Like from perspective of Postgres, coordinator and worker are different Postgres clusters because they will have different system identifier. But from perspective of Patroni, we need to combine them logically together, and therefore we have to define the scope the same on all nodes. At the same time, the group ID must be different for coordinator and for workers. For coordinator, the group ID must be 0 because it is how it's defined inside Citus extension. And for worker nodes, the group ID must be just unique and the integer, like 1, 2, 3, and so on. And last but not least, we need to specify in which database we want to have our data, where we want to create our Citus extension. And in this example, it's a database named Citus. How to solve problem of scaling out when we add in the new workers? It's also very simple. We just create a new Patroni YAML file, Patroni config file, and there are a couple of parameters that needs to be adjusted. Of course, it's a unique name of this node, the Citus group, which also must be new. And it should not be the same as on existing nodes. And we just start Patroni with a new configuration file. Basically, that's it. But after that, this node starts completely empty, and we need to move some existing data to this node. And for that, Citus provide a user-defined function, UDF. It's called Citus rebalance start. Starting from Citus 11.2, it's possible to rebalance data without keeping client connections open. Basically, you start this job and you can leave. At the same time, if you are interested about the progress, you can use the other UDF called Citus rebalance status to check the progress. So, all right, I believe it's enough theory for now, and let's do a live demo. Let's see how it works in practice. To do a live demo, I'm going to use Docker Compose and Docker to start a bunch of containers. I already deployed it, and we got a bunch of containers running. But while they are starting up and cluster is being formed, let's look at Docker Compose configuration. In the configuration, we have a etcd cluster, which consists of 3 containers, and 3 it's a minimal number for etcd to become highly available. It means that every node of etcd could be lost, and while there are 2 remaining nodes that keep running, it will be still running and response on any kind of queries, reads or writes. We also have in the manifest HA proxy container, which provides a single endpoint and can connect us to either to coordinator or to worker nodes. We have 2 containers with coordinators that also create a highly available cluster for Citus coordinator nodes, and 2 pairs of containers with workers. Okay, so we can go inside a container and check the status of our Patroni Citus cluster, and it's up and running. We got 3 leaders, 1 for coordinator and 2 leaders for worker clusters. And here we see, like if you are familiar, if you are existing Patron user, you will see something not familiar. So it's a quorum standby. Basically, at the same time, it's a version of Patroni which is not yet even in the master branch, and it shows that quorum commit feature is working. Let's connect to our database, to the coordinator. It is accessible via HA proxy on port 5000. And we can check pgdist node table, which contains Citus metadata and contains all nodes of our Citus cluster. And we see that the coordinator primary and 2 standby, 2 worker leaders primaries are registered in pgdist node. We can also check extensions that are created in the Citus database, and we see a Citus extension, but it was obvious, otherwise we will not see pgdist node table. What else I'm gonna do? I will add some test data, and I'm using for that example from Citus documentation, because otherwise doing rebalancing will be very boring. And the last thing that I'm gonna do, I will create yet another table, make it distributed, and start inserting data into this table with like interval every 100 milliseconds. While inserts are running, let's add some new nodes to our Citus cluster, but to the group 3. We again deploy our Docker compose. Existing containers are up to date, but 2 new containers are started. And again, go to the HA proxy container and check Patroni control list. And voila, so the third node already is added to the Citus cluster, the third worker. But while it's being set up, let's do a switchover on one of the worker clusters. Let it be cluster from group 1. But Patroni control tool switchovers are just the current running primary on this cluster. It also asking to which node you want to do a switch. You can either specify a node or you can leave it empty. And when you want to do a switchover, you can do it either now or you can specify any arbitrary time in the future. So it will be done at let's say deep at night when everybody is sleeping and not so much traffic, and we will do it now. And the last confirmation, and switchover starts. All right. As you see, the query latency was around about 10 milliseconds, like the insert latency, but during the switch, it jumped just to 3 seconds. It could be sometimes a bit more than 3 seconds. It could be a bit less, but it's this is how switchover manifests itself, and it's possible thanks to Citus' ability to pause client connections to the coordinator. Of course, unfortunately, if you are sending queries directly to worker nodes, it will not work so flawlessly. But this is still a nice feature that works right now. If we check Patroni control list, once again, we will see that switchover completed, and worker in the group 1 already is on timeline 2, and everything seems to be nice. And our queries are still running. So the next thing that we're gonna do, we will check Citus shards table. We want to see how our data is distributed across worker nodes. And because when we inserted this data, we had only 2 workers, and therefore we see only 2 nodes which host the real data, except one table, which is geo IPs, and this table is not distributed but a reference table, and therefore it's also hosted on the coordinator. After adding a new worker node, we want to rebalance existing data. And for that, we will use Citus rebalance start UDF. And we also can check the progress of rebalancing. And it's quite a neat feature. And at the same time, we will see on the left side on the screen that transactions are still running while data is being moved between different workers. It does not really affect existing transactions because under the hood, Citus uses logical replication. And instead of blocking writes to the shard table, it just takes a very short lock when it needs to do a final switch. Right now, out of 11 tasks, 7 already done. We can check again Citus shards table to see that the new node got some data and it indeed some data moved to the new node, which is pretty neat. And we also have it for free, as I said. And while we were talking, the finally rebalance finished, and we are good. So basically, just in a few minutes, we not only deployed a new shard, but we also successfully scaled it out. And now it was it for the demo. Can we get back to the presentation? Yeah, thank you. And it's time to wrap it up. With Citus and Patroni, we can have an enterprise-grade solution that allows that makes Postgres not only highly available but also scalable horizontally. You can start with very small scale, just with a couple of worker nodes, and scale out later when there is a demand. In case if there is no demand, actually you can even scale in, which requires a bit more manual work than scaling out, but it still works. And what's also wonderful is that everything is open source. Postgres has a very good license that allows you even to fork or maybe even sell if you want Postgres. Citus is also an open source extension, maybe not with such good permissions as Postgres itself, but still it's open source, and Patroni also an open source tool. And you can get Patroni and Citus on the GitHub. You can install them and use it for free. And that was it for my presentation. Thank you for listening. I hope you enjoyed, and now I'm ready to answer all questions.
Awesome. That was really, really good, Alexander. Thank you. And yeah, a demo. It's always good to see something in action. And yeah, and you didn't have a backup demo recorded either, and you knew it was just going to work, which is great. Yeah,
so sometimes I script my demo so that I don't have to type anything, but it looks also boring because you know, so it's already scripted and nothing can go wrong. But sometimes when you screw it up or you can do some little variations, it's also nice, in my opinion.
And so I guess most Kubernetes fans will be at KubeCon. That's also being held right now. But I think in like you showed Docker Compose, is there also any Kubernetes integration?
Well, yeah. So Patroni like natively integrates with Kubernetes. It makes Postgres Kubernetes native, I would say, and it started doing it before it became a mainstream, as some other companies saying right now. Basically, Patroni works on Kubernetes starting from 2017, and now you can also deploy Postgres with Citus on Kubernetes, and it will work the same way as I did currently with Docker Compose. Basically, everything is declarative, but to get the best, you probably need to wait until some Postgres operator will get some Citus integration. But at the end, it will be handled by Patroni. So all these features that I showed will work the same way.
That sounds very cool.
I know there's another talk. It's an on-demand talk at CitusCon, an event for Postgres called Citus on Kubernetes. And it's about, isn't it about the new operator from StackGres?
It's I think so, yeah. Not totally new, but it's existing operator, but they are working on adding Citus support, and they have quite a good progress.
Yeah. I was reviewing the captions for Elvato's talk before it went live, so it published yesterday.
Great. I would recommend all Kubernetes fans watching it.
Yalta, or other questions that we definitely wanted to answer? I think we have time for one more.
So let me take a quick look. So yeah, what future improvements have you planned for Patroni? Like you added Citus support recently, so what's sort of the next big thing?
Oh yeah, so that's a great question. The one very major thing, it was like partially revealed in this demo. It's a quorum commit feature, so that Patroni can not just stick to a single standby as a synchronous, but it will add all the existing standbys that are eligible to be synchronous ones. And when failover happens, it needs to query all of them to get the quorum number of votes to be promoted, something like this. And it will decrease latency when synchronous commit is enabled, and of course, it will also improve availability. So it's going to be a great feature.
That sounds amazing.
So for
and it will work with Citus too, right?
Yeah, for sure. And as I showed in the demo, it yes. does work with Citus.
For those of you watching, Alexander is probably going to hop over to the Discord. And are you going to be publishing your slides from the talk?
Yeah, for sure, okay. For sure, yes.
And I know that all six...
I will put them to speaker deck.
Okay, awesome. And all 6 of the live stream talks today are available for replay. We'll post that link in the Discord as well, or actually I have it right here. Watch the replay of the Americas live stream and the EMEA live stream. This is a playlist of both live streams that I'm showing in the bottom of the screen. So if you missed part of Alexander's talk, or you want to go watch his demo again before we publish it as a standalone video, you can go do that right now. So thank you very much for being part of CitusCon this year, Alexander.
Yeah, welcome, and see you on Discord.